Okay, so on this one, this is the last part of section 2.2. This will be the third assignment. Okay, on this one we're going to talk about how to take derivatives of rationals. And this will be one way to do it. I'll show you another way later on. So let's take a look on this. Now, important rule of thumb when dealing with rationals. Break up the numerator in two parts. Do not ever break up the denominator. That is illegal. That will send you to the math pen for sure. Do not ever break up the denominator. Always break up the numerator. And let's work through an example of this. F of x is x cubed minus 3x squared plus 4. Now you notice I have three different terms up here. I've got an x squared, I've got this one, and I've got this one. So if my denominator is right, where it's just a single term, I should be able to break these up. And sure enough, my denominator is x squared. And we want to find the derivative. So what you do is you rewrite f of x, and you break each one of these up into a fraction. So I will have x squared over x squared, because this is my common denominator. Okay, we've always told you over and over and over again, whenever you do this, to combine your terms, right? Yes, we have. Even I've told you to do that. Well, now you're in calculus. You're up in the big kids' math. Up here, you actually do it just the opposite. In order to do this right, you're actually going to break these things up into each one of their things. So I've got this term. Now I do this one, so it's going to be a minus. Oh, and by the way, that should be an x cubed. So I've got a minus 3x squared over x squared. And if you're keeping track, you can see something wonderful is going to happen here. Most of you bounce up in your seat, and then I do this. Ew. Well, not a problem. The first thing we do is simplify. X cubed over x squared is going to give us x. Those go to 1, so it'll be minus 3. Plus, you notice this is in the denominator, so I have 4 times x to the negative 2. All right, now it's easy enough to find f prime of x. We go back in. So I'm going to have d dx of x minus d dx of 3 plus d dx of 4x. d dx of x gives me 1. That's 0. Because you multiply, that's an implied 1 in both of these. 1 times 1 is 1. Subtract 1, you get 0. X to the 0 is 1. Okay? And then plus, and this should be 4 times x to the negative 2. So I do negative 2 times 4. So we've got to change the sign. 1 minus 8x, you're going to subtract 1 up here to the negative 3, which is 1 minus 8 over x cubed. And that is how you handle these types of things. Let's work another example. I've got g of t will be equal to t squared minus 4 over t cubed. Okay, so what are we going to do with this thing? Well, if you've been paying, we want to find g prime of t. If you've been paying any attention at all, you notice I break it up, so what I'm going to do is do d dt because t is my variable of t squared minus d dt of 4t to the negative 3. Okay, now we just power roll this thing. So that's going to give me 2t minus, multiply these, 12t, subtract 1 to the negative 4th, which is going to be 2t minus 12 over t to the 4th. And that is how you do this one. So don't get lured in by thinking you need a common denominator. You don't in this case. All you have to do is rewrite this term as a rational exponent, and you got it made. Okay, the last thing is we're going to find locations where we have a horizontal tangent line. And let's just take a look at a visual example here. I've got a nice little parabola. So horizontal means going in this direction, all right? Now, we should recognize the fact that, and in this case, it's going to be right here. So there's my horizontal tangent line. Should recognize that the slope of a horizontal line is 0. This is going to come back when we do optimization. Okay, in a parabola, this would be a minimum point. Okay, so what we want to do then is we want to find where the derivative is equal to 0. Once you solve for the x value where your derivative equals 0, you found the point where it's a horizontal, where you have a horizontal tangent line. Because that's the point where the slope of the tangent line is 0. And that's the whole point here, is you're going to go in, you need to take the derivative. So the first thing you need to do is find your derivative. Set it equal to 0. And then solve for x. And then plug x into your original equation, not your derivative, but f of x to get the y value. And that's how you find the slope where you have a horizontal tangent line. You take advantage of the fact that a horizontal tangent line has a slope of 0.